Hello grade 12s. Today I'm working through a past exam paper. As you can see, this is the 2019 paper 2 IB, and I'm doing the Loci question 2. Now there was a new examiner in 2018 and he changed the format slightly, and he asked in the 2018 paper only a Loci Cam, and again in the 2019 paper he only asked the Cam. So what that means is that there's going to be more marks awarded for your displacement graph, there's going to be more marks awarded for your Cam profile to make up that 40 marks. For a number of years they've asked the Loci, and part of that was the Cam and the mechanism, and that meant that quite often the Cam mark was only 25 marks. So what you need to be prepared for, this is your matric final, you need to be able to draw everything, the different types of motion that they give you in the Cam, simple, harmonic, and uniform acceleration and retardation. There is the possibility that they will give you a roller as the follower as well. So we're working on that. Mark allocation 40, time allocation the same, 40 minutes is how long you want to try and have to complete this drawing. So here is the question, and you can see they've given you some information here. They've drawn part of your profile, they have drawn space for you to put your label for your displacement graph. They've given you what this profile looks like. Now the key aspect here, very important, is that this center point is what we project across to our displacement graph, and when we project back to our Cam profile we project, and that goes to the center of this point, and at each point we then draw the circle. So that's very important. Now I like to try and get some marks on the board by doing some of the basics, drawing the Cam shaft, hatching that, drawing the follower, so I've got some marks, get the label on. Okay, so I'm going to start by doing those aspects, drawing my Cam shaft, hatch that, draw my follower, and label my displacement graph. So I've put in my label, I have hatched my Cam shaft. This is where it's nice to have a circle stencil. Of course you can draw those circles a little bit faster with your circle stencil. I've put in my direction arrow, which is telling me that it is rotating clockwise. I'm just going to finish this off by drawing my follower. And there I've done the basics, got my direction, drew my Cam shaft, hatched that, I've drawn the follower, and I'm now ready to look at completing my displacement graph. They are going to ask you 3 different things. They'll ask you uniform motion, simple harmonic motion, and I'm surprised they didn't ask you uniform acceleration and retardation. Okay, so they've only asked us 2 types of motion here. Uniform motion has already been asked there, so this is actually quite easy. Simple harmonic, to me the S is the key there. Simple and circle in Afrikaans implies that we need to use our circle divisions to calculate the height. Okay, so from this point we're projecting the center across, because that is the important aspect. So from here it says the follower rises 28. Sorry, from 0 to 60 the follower is at rest. So let's go across there. 0 to 60 the follower is at rest. from 60 to 120 it rises 28. Okay, I've got a feeling it's probably supposed to be exactly to the top of that. So there it's rising 28. From 120 to 165 the follow is at rest. So 165 is the middle of this. If we check what this measurement is here, they've got it as 8. So at 4 we're going to have the half measurement. So here is that aspect at rest. And let's just put that in 165. So from 165 to 255, again 255 is going to be the middle of this measurement here, mark off 4. And put that in. Now what we're going to try and check is how many divisions we've got here. So there's 0, 1, 2, 3, 4, 5 and 6. So if we put in half measurements in all of these, we can get 6 divisions. And it falls 56. So what I need to do is measure my height of half of 56, so I need to draw my circle. Okay, so 56 is going to be the height of this. So what I'm going to just do is bisect this line. So here is the center, and what I'm going to just do is draw my semicircle. Check that it's touching top and bottom. There's my semicircle. Put in your divisions. Okay, there are your divisions. Now, I'd like to just label them to match using the theory of 2 points. So that is my first pizza slice, 0. Second pizza slice is 1, 2, 3, 4, 5, and my last one is 6. Then line them up. 0 and 0 means it's at that point. Here is point 1, and I then take point 1 on my circle and project it to hit, and that gives me point 1. Here is point 2, I project that to hit vertical line 2, and that gives me line 2. 3 is at the center here, and that's going 3, projecting line 4, 5, and 6 is going to be at the bottom. Now when we join these up, let me just zoom in. So when I'm joining these up, the middle 3, so 2, 3 and 4 should be on a straight line, and that's a test of your accuracy. Okay, so you're happy that that's on a straight line. Then let's curve this bottom corner into point 1 and take that to 0.2, from 0.4 into 0.5, and hockey stick curve into the end point over there. Okay, from 255 to 300, it's at rest. So there is that horizontal rest. And then from 300 to 360, it returns to its original position. So there is our original position. And let's join that up. Okay, so let's just double check that. From 0 to 60, that's at rest. From 60 to 120, that's 120. The follower rises 28, sorry. From 120 to 165, yes, it's at rest. Then it falls, the whole thing with simple harmonic motion, yes. Then it's at rest, then it returns to the original position. Okay, so I think I've got of the information here that I could check. I have drawn and hatched the camshaft. I've drawn the roller follower. I've done the graph. I've drawn the direction. Okay. Now we need to do this, draw and label all the divisions. Okay, so I'm just going to zoom out. There I've put in quite a lot of my divisions. Please, let's just remember, they've said the cam profile is rotating clockwise, which means the first division will be on this side because that's the first one that comes past the roller. So the roller is always 0. Because we're rotating clockwise, we label in the opposite direction. What I also need to do is include 165, 195, 225 to get these extra measurements that we've got there. So that will be 225 will be here. And it is 265. And here is 285. What I needed, 240, 265. I needed this one. So there have all my points been plotted off. So I've done that aspect where they asked us to now draw and label the divisions on the cam profile. Okay, draw the cam profile, that's what we're going to do now. So we need to project our points across, always to the vertical line, show a couple of them and project a couple. But then save some time and line it up, make a mark here, line up, make a mark. The same with your arc, line up the arc and then just transfer the measurement. Don't waste time drawing each arc all the way around this page. That's going to eat into your time. So my first lot of measurements of 30 and 60 is where it's at rest. So my first point really is here where it's hitting 90. So I'm going to take that across and label it as my 90 point. Again, let's transfer some of our measurements to show our construction. So there, this point was going at rest all the way around to point 60. Then we only needed to go to point at 90. Okay, so I've done enough construction in my opinion now, and what I can do is just save time now. So my next point is here at 120, and I'll take that, line it up and mark it off. Now 120 is going to 165 at rest. My next point here, line it up, transfer it across, label that, is at 180. My next point here is the same point at 195. This point is at the same point at 210. So let's transfer those ones. So take my compass. This point is 120 to 165. So 120 to 165. So I haven't drawn that in. Okay, there's 165. Here is my 180 point, line that up, transfer that to 180. Again, I'm not projecting it all the way. Here is 195. Transfer that to 195. 210 is at the same point here. And there's 210. I've now got to project my other points. So here is 225. Here is the bottom of my graph. No, here is 240. The bottom of the graph here is at 255. Okay, so let's do that segment now. So here was my point at 225. Here's my point at 240. Here is 255. Now from 255 to 300 it's at rest. So what I can actually do is take that around to 300. And my last point here is 330. 330. Set my compass to that distance and transfer that to 330. Now here is that huge thing that we need to remember. At each point we now need to draw a circle, or I'm happy just to draw a semicircle. If you've got your circle stencil, line it up with the arc and your division and draw the follower. Just remember, each point is to the middle of the follower. So we now need to put in the shape of the semicircle. If you had to just join it up now, you would be 6 millimeters out for each point, which is a huge difference towards your accuracy and your mark allocation. So please don't forget to draw the circle, or I'll just do a semicircle. Again, just to save some time. So I'm setting my compass to this radius of 6. And I'm taking that and going to the intersection there, and I'm drawing a semicircle. So my happy face. Okay, and there we've got all of our points. Now, when we join this, if you can, use a flexi curve or French curves. And what you're trying to do is find the tangent to this profile. So for example, where this point's going to hit here, it's probably going to be there and not at the intersection of the division. Okay, so just understand it's different to the wedge-ended follower, and when we draw this cam profile, it's got to be a smooth profile for this roller to run on, and not sharp little jagged points. Okay, and that's why it doesn't necessarily hit where the actual intersection of the roller and the division is. It's at a tangent. Okay, so let's try and join these now. Here's a good example of where it's definitely not touching that intersection. I'm trying to just get a nice smooth curve for the roller. Looking a little bit like a kidney, I think. And there is the completed cam profile for the 2019 paper. I think a little bit easier. They didn't ask you uniform acceleration and retardation, only simple harmonic motion, but the change was that they did have a roller in this, and we needed to remember that at each point then we've got to draw the roller for the roller follower, which will change where our cam profile will be. My time now is 2:13, which means I have saved myself 12 minutes, which I can then add into another drawing. Sorry, there it is, 12 minutes I've saved, which I can now add into another drawing.